Drive through the American Midwest today, and you'll see a landscape of highways and farms. But hidden beneath the surface of this familiar terrain are thousands of massive, mathematically precise geometric earthworks built centuries before the first European arrived. Early settlers often mistook these formations for natural hills. Because they were searching for stone ruins like those found in Europe, they struggled to recognize a sophisticated civilization that used the soil itself as its primary architectural medium. A shift in perspective came in 1848. The newly founded Smithsonian Institution chose for its very first publication a massive analytical survey of these sites by researchers E.G. Squire and E.H. Davis. Squire and Davis spent years mapping these structures across the Mississippi Valley. Their work revealed that the earthworks weren't random piles of dirt, but part of a continent-spanning system of highly engineered infrastructure. By analyzing the specific structural blueprints of these mounds, we can see the footprint of a massive civilization that mastered large-scale engineering using earth rather than stone. The largest categories of earthworks are the enclosures. We can distinguish between a military fort and a temple by looking at the specific placement of their perimeter ditches. Defensive works are usually irregular in shape. They occupy high, inaccessible hills and trace the natural, jagged contours of cliffs to maximize their tactical advantage. This schematic shows a typical defensive layout. The protective ditch is dug on the outside of the walls to create a secondary barrier that any attacker would have to cross before reaching the embankment. Sacred works follow a different geometry. These are built on flat river terraces, forming perfect squares, circles, and octagons that can span hundreds of acres. In these geometric enclosures, the ditch is located on the inside of the wall. Placing a ditch on the interior makes a wall easier to climb from the outside, which defeats the purpose of defense. This indicates the space was intended to be a consecrated area, separated from the outside world by a formal boundary. This is the Marietta Mound in Ohio. It represents the conical mounds often found within these enclosures. To understand how they functioned, we have to look at the internal engineering hidden beneath the surface. Sepulchral mounds are simple monuments to the dead. These are unstratified cones of earth built directly over human graves. However, Squire and Davis identified a second, more complex type, the altar mound. This cross-section shows the internal engineering of an altar mound. It is constructed with alternating layers, or strata, of gravel, sand, and clay. At the base, researchers discovered perfectly symmetrical clay altars, showing evidence of intense burning, with scorched earth preserved at the core. The deliberate layering of earth over these burned altars indicates that these were sites of repeated, choreographed religious sacrifices. The construction required a sophisticated understanding of geological materials to preserve the site over time. Moving further south along the Mississippi River, the structures shift toward a completely different form, the temple mounds. These are truncated or flat-topped pyramids. They feature graded ramps and spiraling pathways, leading to massive summits that cover entire acres. This photograph shows the iconic and massive Great Pyramid of Giza in Egypt. It is a helpful baseline because several of the earthen temple mounds in the south rival this structure in total cubic volume, representing a massive investment of manual labor. These flat-topped pyramids served as monumental foundations. They were engineered to support massive wooden temples and council houses, lifting the civilization's political and religious centers high above the surrounding landscape. Looking at the entire Mississippi Valley today reveals thousands of these distinct, highly engineered earthen structures across the map. Moving millions of cubic feet of earth with this level of geometric precision required more than simple labor. It required advanced mathematical planning and a highly organized workforce. Such a workforce could only be supported by a society with a significant agricultural surplus and a centralized leadership capable of managing large-scale infrastructure projects. The ancient Mississippi Valley was a thriving, engineered world where builders mastered their environment, using the earth to create an enduring legacy.